Hi, welcome to today's Introduction to Solar Systems webinar. My name is Sean Foster. All PGE seminars and webinars are in part sponsored by the Energy Trust of Oregon. We work together to make sure the concepts and recommendations you learn in our events are consistent across all of our individual programs and services. And so first, we just want to talk really quickly about what we're going to look at and cover for the day. We're going to start with solar energy basics, then touch on solar thermal systems, and move into solar electric PV systems. And then lastly, touch on incentives and some additional resources and wrap up with a Q&A. So first we want to start off with a quick question to everybody participating. Just really quickly, there are some choices up there. If you wouldn't mind using the annotation tools on the left, if you wouldn't mind marking up what describes your role most closely at your place of business, so that way it may potentially help us cater what we say. Otherwise, we'll try and speak just in general terms. Looks like we've got a couple of answers in. I'll give it another second or two. All right, looks like we've got some facility folks, some sustainability folks, maintenance manager, et cetera. So we've got some varying roles, and so we'll try and keep it fairly general, and hopefully it gives you the information that you are looking for. So first, let's talk about some basics of solar energy. Solar energy is one of the best options that we have for a renewable resource, and you can see by the numbers here that it certainly provides enough energy. The challenge is, how do we harness it as humans in a cost-efficient and effective manner? You know, for instance, the sun puts out greater than 10,000 times the amount of energy that we as humans need. Like I mentioned before, the challenge is, how do we harness that effectively? And so hopefully these will give you a couple of ideas of potential projects that would allow you to do so. So where is the U.S. in terms of utilization of solar? Well, we're trailing, but we're starting to catch up. The U.S. is represented by this mint green color here. If you look in comparison to, let's say, Germany, or even in Italy, for instance, we're trailing behind, but we are catching up. Solar deployment in the U.S. in the last 5 years has grown exponentially, and we've got some charts that'll show that a little bit later on. And with currently available incentives, solar energy is really going in collaboration with the fact that solar prices, installation prices, are coming down.
Sean, why has the U.S. lagged so far behind in the past?
One of the reasons is Germany, Italy, some places in Europe, they've instituted and have for several years what are known as feed-in tariffs, which incentivize the installation and deployment of solar at an earlier rate and a more intensive rate than the U.S. The U.S. is a country obviously made up by 50 states, and each of those 50 states have their own policies and drivers for the adoption of solar. You know, some areas of the U.S. are rapidly deploying solar, obviously the Southwest, California, but places like Massachusetts, New York, New Jersey are also doing it. But there's a big, majority of the country that haven't been to date, and it's a lot to do with the fact that we're 50 individual states that don't follow all of the same policies, whereas countries like Germany and Italy, when the national government there sets a rule or a tariff, the whole country follows. But that's it's easier for them to do because of size and population numbers, et cetera. Here's another chart to illustrate what I was talking about how solar deployment in the U.S. has grown exponentially. Let's look here at 2010. Had 852 megawatts installed in 2010. Let's look at last year, 2015, 7.2 gigawatts of solar installed. And the other thing I want to call your attention to in comparing the 2 years is the breakup of class that's installing the solar. You know, you had a pretty relatively even distribution between residential, non-residential, commercial, industrial, and utility scale. And look at 2015 and notice that residential is still installing at a pretty rapid pace, but utility scale started going at a pretty rapid pace, and that's because costs have come down. Utilities are generally a least cost type of operation, and that relates to the fact that solar costs in general are coming down considerably and have been for the last several years. There's a misconception that power companies have a difficult time integrating PV power, but it's not the case at fairly moderate levels. And this is just an example from back in 2012. At one point of a particular day, the PV portion of the German grid was able to generate 40% of that country's electrical needs for that moment in time. Over the course of that day, the PV portion of the grid generated an average of 20% of the electrical needs for the day. Back in 2015, I believe it was, they actually experienced a total solar eclipse during the daytime hours, and there was a lot of concern from utility operators that the systems there wouldn't be able to handle it. And for instance, in Germany, the grid went from approximately 20 gigawatts of PV capacity to almost zero and back up to 20 in about an hour's time as the solar eclipse began, went to total eclipse, and then ended. And they were able to, by the methods that utilities use for integration, control the power grid in a reliable and safe way, that they were able to handle that total solar eclipse without having any negative experience for customers whatsoever. And it was a true test for the grid and integration, and it came through quite well. You would have heard about it. It would have been a much bigger deal if something bad would have happened, and the fact that most people hadn't heard of it or of the concern just goes to show that it was handled quite well. Now, what about solar in Oregon? As we've talked about, Germany has considerable solar capacity, but it may surprise a lot of folks that Oregon has more sunshine than Germany on a yearly basis. Obviously, our winters here get a little rainy, get a little cloudy. Who are we kidding? Get a lot rainy and a lot cloudy. But our summers are fairly sunny, and they more than make up for it. And so annually, we end up with more of a solar resource than Germany, who has all of that capacity. Time for another question for folks attending. Just to give you a brief question on what we've talked about already, mark what statement is true. And remember, use those annotation tools on the left. All right, looks like we've got some answers coming in. And you've got it right. The answer is B, that our production is low in the winter, but our sunny summers more than make up for it. We definitely don't yet have the world's largest PV capacity. We are here in Oregon more sunny than Germany, and Germany, at least at the time of that chart, had not generated 60% of its electricity by using solar. All right, let's move into solar thermal systems. There's two main types of systems we're going to talk about: solar thermal, which often is just more commonly referred to as solar hot water heating. And then later on we'll touch on solar electric, solar PV. Another quick question, and this speaks specifically to the topic we're going to talk about next, and that is, how important to your facility are hot water energy costs? How important are those to your financial bottom line? Are you a hotel that has a pool, does a lot of laundry? Are you a laundry business? Are you a brewery? Are you a food processor? Do you use water for other industrial needs? And again, those annotation tools are available to the left. Okay, some answers coming in. For those of you who say it's somewhat important or important, you may want to pay attention to this. If you use a considerable amount of hot water, it's surprising how much potentially you can save with a solar thermal system. So this picture right here is at a local brewery in southeast Portland. It's at the what's called Lucky Labrador Brewing Company, and those are solar thermal panels installed on the roof, and they actually brew their beer with water heated by this system. This system had a simple payback of about 2 years when it was installed, and that is before you take into account all the great publicity from the installation. You know, in our area, sustainability matters, and people will frequent businesses who are very public about doing sustainability type projects, and so, you know, the increased PR probably helped them a little bit. Solar hot water collectors are 3 times more efficient than solar PV, and we're going to frame some of the discussion today around the concept of what these technologies mean for your home. Not everybody's a facilities person, not everybody is a maintenance person or an operations person, and so not everybody have the context to view things from the industrial lens with respect to how their facility works. But generally everybody lives in a house, and you can relate to things on a personal level, and so with that being said, you just scale up from some of the items that I'm talking about to frame it in a commercial context. An example of that being a typical Oregon household can save about 50% of their hot water heating costs by using a solar hot water system. And as you scale up, you know, the same thing can apply for two businesses as well. So solar thermal systems are fairly modern these days. One of the problems with solar thermal energy is that it has been, for the last couple of decades, overcoming a legacy of the many systems that were installed back in the 70s during Jimmy Carter's efforts to save energy with solar energy. They weren't well-built systems. They weren't well-engineered, but they've improved dramatically in the last 30 years. They last a long time. They don't generally need a lot of maintenance so long as they're installed appropriately and maintained appropriately. They're very efficient. They do provide a good return or payback when done in the right applications. So like I mentioned before, breweries, hotels, laundries, food processors, etc., and they use reliable electronic controls these days in comparison to what was available, you know, 30 and 40 years ago. This chart is from Oregon Department of Energy's website, and it just goes to show the amount of energy available in a city in Oregon, specifically Salem, and how that relates to other cities across the U.S., North America. So here's Salem here, the green bar, and as you first look at it and you think, oh gosh, it's the lowest, but you know, let's look at it in terms of how low it is relative to even the highest, you know, which is Los Angeles and Reno. It's not that far below, and Puerto Rico, most would say, is a sunny place, and it's pretty darn close to Puerto Rico. And so there is some substantial solar energy available here in Oregon, and we just need to install ways to harness that. Let's talk about how the systems work. Water is typically the choice of most systems to act as the heat transfer liquid that moves the heat around. Sometimes you'll mix in antifreeze if you have worry of a freeze. Just so it should be noted that typically the water that you're heating up here on the panels isn't typically the water that you're actually then using or consuming. And again, this is using a simple example that you may often see in the home, but the same concept applies, just scaled up in a larger context for businesses and industrial users. And so what you typically see is you see the sun here, of course, shining down on these solar collectors. That water or liquid is then heated, run through pipes or tubing to a heat exchanger in your hot water tank. and it's similar to like a radiator in a car or in an air conditioner or heat pump. You then have a heat exchange to the actual liquid that you're going to be using and or consuming. The water transfers its heat to the usable water, the potable water, and then it's cooled down. It then flows through by way of a pump back to get heated again. Thinking about this terms of a residential systems, again, let's look at the diagram so we can see the typical solar system is put together. Here's the thing to recognize is that the solar thermal system simply augments the regular water heating. On cloudy days with less solar energy, the normal water heater will still be able to do the work. On sunny days when the water is being heated by the sun, the normal water heater runs much less, saving you money. So here is an example of the system with that heat exchanger essentially extracted out of the larger water heater. So here you have your selectors. Let's pretend there's a sun up here, sun shining down on the collectors, heating the water, goes to the heat exchanger, transfers the heat to the water you actually consume, and then if it needs to be heated more because, and thank you to Beth for drawing a sun on our slide, but then the heated water that you consume goes to the water heater where if it needs to be heated more, it is. If not, then it just goes and sits in an insulated tank until it needs to be used. Cold water obviously then returns to capture more heat from your circulating system over here. There are two basic types of solar thermal collectors. The first we want to talk about are flat plate collectors. A flat plate collector is basically a flat box that absorbs the sun's energy and has pipes running through it that are then also, of course, absorbing that energy. You can see here when you look at the box that there are pipes running vertically here, well, diagonally, if you will. The box is lined with the black material. Black, obviously, as we know, attracts the sun's energy more efficiently than any other color, and so it draws the sun's heat in, heats the water in the pipes, which then goes to heat your home or your business. The other common type of collectors are called evacuated tube collectors. In this type of collector, the pipe with the water in it is actually inside of an evacuated tube. And so here's the pipe. What you have here is then an absorber plate, so it's kind of like the black material. It attracts the sun's heat, then heats the water through this copper tube. And then much like a thermos, you have two external layers. In this case, you have glass to let heat through. You have one layer, and then you have a space that would normally have, air and an atmosphere in it. And then you have an outer layer. But in an evacuated tube, much like a thermos, you vacuum out that atmosphere, and it reduces the ability to transfer heat, and so you trap that heat that you capture inside that tube. Flat plate collectors don't perform as well as evacuated tube collectors, but they are less expensive than evacuated tubes. Evacuated tubes are the Cadillac, if you will, of solar thermal. What's the best type of collector? There's always a lot of discussion when it comes to this question, and good reasons to use both types. We would recommend that you really follow your designer's opinion on the issue. They would be familiar with what works best in your area and also in your application, and should be able to provide proper solutions for you. So let's talk about what sites are good hosts for solar thermal systems. Anything with a large daytime hot water need, so a laundry, again, breweries, hotels and motels, because of obviously the laundry need, but also the fact that a lot of them have heated pools. Any industrial users of hot water, dairies, of course, and food processors as well. They're all good sites for solar thermal systems. And remember, these systems are scalable, and there are some economies that come with scaling up in size. So the best sites for solar thermal are those that use a lot of hot water. It's just important to remember to analyze what are your hot water needs when thinking about whether or not you should look to install a system or not. Watch your potential site during a sunny day to see how the exposure is. Look for shadows from trees and buildings over the course of the day. You want to look for locations that obviously have space for your collectors. You want to look for locations that have space for the collector mounting racks. You want to make sure where you're putting them can carry the weight. So you're not talking about just the collectors, you're talking about collectors full of liquid, and then potentially in the wintertime you're talking about collectors that may have got some snow or some ice on them. And so your weight needs to be able to, your structure needs to be able to carry all of that weight. If you're putting it on the roof, you need to make sure the roof is in good shape. These systems will last, 10, 15, 20 years and more, and so you don't want to put them on a roof that'll need to be replaced in 5 years, because then of course you just have to remove your system while you're replacing your roof, and that increases the risk that you can damage the system, but it also reduces the time that your system's operational, and which then reduces payback. You definitely want to have a good south or mostly south exposure. And as mentioned before, you want to have good sun available from 9 a.m. to 3 p.m. with very little shading. And some of these concepts will apply later on to solar PV as well. Cost and benefits, let's talk about how much it costs. Both solar thermal and solar electric systems can be built over a wide range of sizes, and the costs are often typically a function of size. For a size suitable for a household for solar thermal, you would figure on between $5,000 and $8,000. We don't install any solar thermal, or we don't often work with many solar thermal customers, and so that's about as good as we can get on estimating costs. Everyone's commercial site is also very different. Your needs are very different. Your roofs are very different. If you have room to mount stuff on the ground versus not being able to is all very different. And so that gives you a ballpark for a household. You'll want to scale it up from there for commercial systems, and also thinking about the fact that you're going to get some economies of scale. This $5,000 to $8,000 for a residential system is for a full system with, all the pumps and controls you need. When you're scaling up, you're not going to necessarily need a bunch of redundant pumps and redundant controls, and so you get some benefit there, as well as just buying in mass and the economies of scale that go along with that. All right, time for another attendee question. Remember to use the annotation tools on the left. Which statement correctly describes solar thermal systems? A, they've improved in the last 30 years or so. B, solar PV systems are more efficient than solar thermal. C, there are 6 types of collectors. Or D, flat plate collectors are more efficient than evacuated tube. And we've got a bunch of answers coming in. Everybody appears to be choosing the correct one. Of course, PV systems, and you'll learn a little bit more, aren't as efficient as thermal in terms of converting energy. There's only a couple of main types of collectors, and evacuated tubes are more efficient. So let's move into solar PV, talk again about technology, what makes a good site, some cost and benefit stuff. In this slide, I'm just trying to refer to some of the key terms used in solar PV systems. As you research PV technology, you'll probably run into these most certainly. There are lots of other components that can potentially be involved, but these are some of the key terms that you'll run into no matter the type and size of system that you're talking about. The array is just an assembly of the panels and strings and combiner boxes that are used to wire the system. So taking a look here are your panels. Typically you have a string of panels wired together, and then multiple strings will then come together at what's called a combiner box. Remember, these panels are generating in DC energy, and so you have to convert that. And that's done by the inverter. The inverter converts DC to AC. It's kind of the heart of the system, if you will. And once you have AC, now you can operate your system what's called in parallel or connected to the utility grid system. In some arrangements, you're going to want to meter what the actual output is of the array. If you want to, from a business perspective, find out how much power you're actually generating, what your payback look like, you're certainly probably going to want to meter that. And then this is to represent a load center for a building. Granted, it looks like a circuit panel from a home, but the same concept applies as if this were switchgear in an electrical room in a factory. And so you can either then power your business, or if your generation exceeds your load, then potentially send power back to the utility. So let's talk about panels. There are a few main types of panels. First, we'll talk about monocrystalline. They're the best efficiency panels out there. They're made from a single large crystal, which is expensive to make, takes a lot of electricity to grow. When you look at them, they look like a solid color in comparison to these over here, which are polycrystalline. And that's because the crystal is typically grown in a cylinder. These monocrystalline panels will typically look like what you see here, and that's because when they're grown round. But when you want to place a bunch of solar cells into a panel, a bunch of round solar cells isn't the most efficient use of the space. And so as you can see here, they shave off the sides. And so what you end up with is when you combine these together, you end up getting what appears to be these little diamond shapes on the panels. Polycrystalline is made actually from liquid silicon that is cooled and solidifies like ice cubes in your freezer. They can look like a crazy quilt of different parts when you look closely at a panel, as you see on the bottom left. Panels of polycrystal don't have the gaps between the wafers because they're cast in square blocks before slicing into wafers, so they fit together much more tightly than monocrystalline do. And one thing to note is while these are represented in blue, you can actually get solar PV panels in just about any color. However, most of them typically are sold are blue or black. Another type of panel is what's called thin film, and that's basically silicon that's printed onto a substrate. It's pretty cost effective to make, but it's not as efficient. It offers about a half of the efficiency that crystalline panels do. And when we're talking about efficiency, we're talking about what's the ability to extract power from the panel divided by how much power is hitting the panel. That's what we're talking about when we're talking about efficiency. The benefits to thin film is it's lightweight, and it can go in applications where the structure of the building aren't quite as strong, or you have let's say a broad warehouse type building, and you have a low parapet or something on that building and you want to hide the panels. Let's say these lay flat. They're essentially chemically bonded, similar to those aftermarket roofs that you can put onto RVs. They're essentially rolled onto the roof and then bonded to the roof. In general, panels are rated in what's called watts at standard test conditions. Standard test conditions is essentially full output under noon sun, and I believe it's at either 70 or 75 degrees Fahrenheit. With solar panels, actually, the warmer it is outside, after you get to that standard test condition, you actually start losing a little bit of efficiency. And so people often think that you should just put solar arrays all over the desert Southwest and in Arizona and Nevada and California. And while it's certainly true they get a lot of sun, they don't operate as efficiently as, let's say, if you had the same size array in a slightly cooler environment, just because as they get hotter, they lose some efficiency in terms of their output. Inverters are available in lots of sizes. Usually the system, usually you size your system and then buy a corresponding inverter, and so you figure out how many panels you need and then find out what inverter is going to work for that big of a system. They all have generally pretty good warranties, typically at least 10 years or more.
Sean, how long are the inverters going to last? I mean, you have a warranty of 10 years, but they look pretty expensive.
Yeah, the inverters are the hub of the system, if you will. Most inverters will last at least 10 years. Most warranties are good for that long. Some inverters will last 10, 12, 15 years or longer. It just depends on if you have a really well-made one or not. The thing about a solar system, a solar PV system, is when you're installing it, The solar panels themselves will typically last for 30 years or potentially more, and given the fact that inverters will last between 10 and 15, you typically, when you're planning for a solar system, you typically plan for at least a one inverter replacement during the lifetime of the overall system. So when you're doing your O&M budgeting for installing a system, you want to include that in your plan. But they do last a good long time, and remember, they're the workhorse of the system. They're the hub of the activity. These two inverters are actually installed at a site just south of Aurora, Oregon. They are 260 kW each. Smaller systems will typically have a smaller inverter, a single inverter per array. Oftentimes, though, arrays these days, you'll have multiple smaller inverters to make up a larger system. The possibilities are endless with respect to how you can configure systems. Another type of inverter is what's known as a microinverter, and so to take what I was describing and expand on that before, where you can have systems made up of multiple inverters. Microinverters typically are either one panel per inverter or two panels per inverter. They're connected to in such a manner they increase efficiency in some applications. They're most often found in residential installations, but I have seen some commercial installations come across. The efficiencies that come across from microinverters are that if you have, let's say you have a large array and you have a string of your panels go out, it's more difficult to troubleshoot and identify where the problem is because you have typically a centralized inverter that the only thing that you see is a little bit of a drop in production, and so you have to go out and get somebody to manually go and test the lines and figure out where the problem is. Microinverters typically these days are hooked up via an internet protocol to a central data hub, and so not only will it tell you if you have decreased production on a panel, if you don't have any production, etc. And microinverters help you avoid issues that are related to shading. Remember, strings of panels are typically hooked up in series, and if you have shading of one panel, sometimes that can have some negative effects on a whole string. Microinverters help avoid that. It's time for another question. And don't forget the annotation tools on the left. And so the question is which of the following panels has the highest efficiency? And I'll just name off what you see. A is thin film, B is monocrystalline, and C is polycrystalline. Looks like the answers have rolled in, and B is the winner, and you are all correct. Here at PGE, we use some basic rules of thumb when discussing PV with customers. They're kind of conservative to some folks, but they're also easy to remember. And so we at the utility are historically conservative in some of the things that we say. And so we don't want to overpromise and then underdeliver. So for our climate west of the Cascades, we often say 1 kilowatt of installed DC capacity will produce 1,000 kilowatt hours per year. You'll find some folks will say it's slightly higher, but like I say, it's also easy to remember, so we just use that number. East of the Cascades, you're going to see a higher percentage, and that's pretty plainly it's because the sun shines over there more. Oftentimes east of the Cascades, you've got parts of eastern and central Oregon that'll get 300+ days of sun a year. And that's just better when you're trying to harness energy from the sun. 1 kilowatt of installed capacity, we typically will say requires about 100 square feet of roof space to mount. And so that gives you a basic rule of thumb in determining how much solar capacity could I potentially fit on my roof. Now remember, thin film requires more space. It's approximately 50% more. But depending on the efficiency of the panels, et cetera, it could be more or less. And 1 kilowatt of installed solar PV for businesses in commercial applications will typically cost anywhere between $2,500 to $3,500 installed. To break that down into an easier number to remember, 250 to 350 potentially per watt installed of the system. Again, site requirements are some of them are very similar to solar thermal. You want to have, full sun from 9 a.m. to 3 p.m. Certainly want to have your building facing south. Again, structural support's important. These panels are heavy, especially the mono and polycrystalline, because you've got metal and glass and silicon wafers. But then also, again, think about what happens in the wintertime. If it's freezing outside, you may potentially have ice and snow that's also accumulating as well. Again, the roof, it's very important that your roof's in good shape. You don't want to put up a system that's going to last for 30 years on a roof that's going to last 5. Because, again, you're having to remove it and increases potential for damage, etc. Of course, you need to have space not only for the array on the roof, or if you're doing a ground mount system, let's say, but you also need to make sure you have space for the wiring and related inverters and combiner boxes, etc., in whatever electrical rooms or raceways, etc., that you're going to potentially run the equipment. Making sure you have space is important. I can't tell you how many times I've helped coordinate with customers when they thought they had more space and come to find out that they couldn't place an inverter where they thought they had to, and so they had to place it somewhere else. Of course, you need to have a connection to the power system. Generally, solar PV systems won't operate unless they're connected to an operating utility grid. That's by design. And from when dealing with your utility, unlike solar thermal where there's no interconnection issues, there's no business arrangement with the utility, when you're talking about solar PV, you want to definitely make sure that you have consulted with not only your contractor but the utility on what is called interconnection. And that's the technical evaluation that we'll do to make sure that the system that you're potentially proposing can interconnect safely and reliably to our system. Are our facilities that are installed currently sufficient to be able to allow for that safe and reliable interconnection? Is there something about your design that runs afoul of electrical standards, et cetera, that we monitor? All of these things are very important. And then remember, with solar PV, it's not just about the physical connection. You also want to make sure that the economics are right. And part of the economics is making sure that you have a workable business arrangement with the utility, potentially involving, third-party installers, et cetera. You need to make sure that that's in place as well. What you don't want to see is somebody install a system that there isn't a proper business arrangement in place or allowed by state administrative rules, et cetera, and then you end up having a stranded asset on there. With commercial installations, the most common problems owners run into with solar are structural issues and cost to get the wiring between the service and the panels. Many commercial buildings are built close to the code minimums for weight bearing limits, and adding panels to the roof adds oftentimes too much weight. And one thing to think about is if you're doing something like, or contemplating a ground mount installation, wiring costs can often get pretty high when you're looking at having to locate and run wiring from pretty far away from the connection point with your distribution system in your facility, and ultimately that then connects to our system. So, siting is fairly crucial when running the economics on a solar system. This chart is just largely to illustrate, some of the reasons that we've seen such rapid deployment in the last few years of solar PV. And this chart stops in 2013, but the point is still made and it's still continuing. The cost of PV systems represented by this dotted line here has gone down, and it's probably no coincidence that the number of systems and capacity has gone up considerably in that same time frame. Costs of PV have been declining steadily and dramatically in the recent past. Factors like silicon availability, other countries' presence in the manufacturing market, incentive availability are all driving volumes up, prices down. As volumes go up, manufacturers also experience those same economies of scale. And like we mentioned before, because of that, a good price range to think about when you're looking at this is anywhere between $250 and $350 per watt installed. Other things to think about with respect to cost on a commercial system, site factors like we mentioned, can your roof support it? Do I have to run wires a long way? How am I going to mount it? Is it going to be rooftop? Is it going to be ground mounted? Do I have to build or buy extra racking? Do I want that racking to be aesthetically pleasing? You know, these things are all considered. Of course, system size plays in because at 250 to 350 per watt installed, it's a direct correlation there generally. Permitting costs. Permitting costs have actually come down a little bit in some of the municipalities around the area, but they do vary, and so depending on where you're at, you're definitely going to want to investigate that. And of course, panel type, the more efficient they are, the more expensive they generally will be. You know, it's the same thing as buying the newest iPhone. It's the fastest, most speedy, you know, unit that company makes, but it's also probably going to be the most expensive. There may be units that are out on the market that will deliver over the long term what you need for potentially a little bit less. Time for another question. Again, the annotation tools on the left. And installation requirements for PV are nearly identical to thermal except for which of the following? Is it A, you want it to be sunny from 9 a.m. to 3 p.m., B, south to near south facing, C, your roof is able to support, or D, utility company provides interconnection and business arrangement? And those answers are rolling in. And yes, the answer is D. A through C are all very closely, very similar to what you experience with solar thermal. And at this point, we want to invite Jenny Hall with the Energy Trust of Oregon, and so I'm going to turn it over to Beth to bridge the conversation with Jenny now.
Jenny, you can go ahead.
Thanks, Beth. Thanks, Sean. I appreciate the opportunity to talk today. Hi, everybody. My name is Jenny, like she said. I'm a project manager with the Solar Program at Energy Trust of Oregon. Energy Trust is an independent nonprofit organization. We're dedicated to helping utility customers like yourselves to invest in the benefits from energy efficiency and clean renewable power like solar. And basically what I'm here to talk to you about today are the solar electric incentives that Energy Trust of Oregon offers PGE customers. We just have a couple of main points to hit. We have a network of solar trade ally contractors who are located throughout the state, and they are familiar with our incentives and the requirements to be eligible to receive those incentives. Many of the requirements are basically the site requirements that Sean has gone over. We have some specifics on those site requirements, but our trade allies are definitely the best able to ensure that your system and your project would meet those requirements. Energy Trust offers an upfront incentive that's based on your system size, and that incentive can cover up to 20 or 25% of the project cost. For commercial customers in Oregon, the next incentive is really the federal tax credit, which is 30% of your out-of-pocket cost. And then you have access to the accelerated depreciation on your investment as well. In Oregon, there is a renewable energy development grant that is available to customers installing solar electric systems. It's a competitive process, and so it's a little harder to predict. The incentives we have listed here can cover up to 80% of the project cost, and those are not competitive, so you can count on these. The easiest way to get started, as I mentioned, is to be placed in contact with one of our solar trade ally contractors, and we've made that process really pretty easy. You can go to our website, energytrust.org/solarbid, and fill out the form that you find there. give a little bit of information about your goals for the project, the location of the project, and you'll be contacted by 2 or 3 contractors who work in your area to provide you a free bid based off of the information you've provided and a site assessment they can do remotely. It's kind of amazing what you can do these days by just pulling up a building on Google Earth. Experienced installers can give you a rough estimate for what would fit on your roof and what a system, a standard system would cost. They're going to have to fine-tune that estimate by coming out to your site, but the first step is definitely getting those rough numbers together. I'm going to stick around here to the end, so if you have any questions for me, feel free to enter those in the box, and Beth will collect them for us. And then with that, I'll hand it back to Sean.
Thanks, Jenny. And with any tax incentive or tax rebate, our recommendation is always to make sure and speak with the tax professionals at your organization, your accounting folks, CFO, et cetera, to make sure that you both qualify for tax incentives and potentially can leverage those. Some additional resources really quickly. We have for solar thermal this homepower.com/basics/hot water. It's a great primer on solar thermal. It goes over the stuff that we have talked about today, but also a lot of other resources available that are available there as well. And again, solar thermal is something that the technology is relatively consistent across scaling up in size, and so it's primarily just to be used as a primer to get you thinking about it. As Jenny mentioned, energytrust.org. That's a great overall site, not only for the trade allies, but also lists potential incentives available, does some discussion with respect to technology, et cetera. And of course, our website, www.portlandgeneral.com. We have several web pages there. If you go to our website and search under renewable energy, you'll find web pages dedicated to things like what you may have heard of net metering, or if you wish to sell power to the utility, et cetera. The interconnection documents can be found there, and links to PGE tariffs, et cetera, which equate to the business arrangements that we mentioned earlier, can be found there as well. Just again to summarize, we kind of talked about some basics of solar energy, and then we went in and talked about solar thermal systems and solar electric PV systems, what makes up the technology of each of those, good site identifying characteristics, some basic cost and incentive stuff. Jenny did a great job talking about incentives and some additional resources. And I think now I'm going to turn it back over to Beth, and we're going to see if we can answer some questions if you have any.
Thanks, Sean. Thanks, Jenny. Before we proceed to the question portion of the webinar, I'd like to remind you that you can continue to submit questions to me, and I will ask them of Sean and or Jenny. And let's see, looks like our first question is, this is, I think, directed towards Sean. I've heard of panels that do both solar thermal and solar PV. Can you tell us a little bit more about these?
Just in general, people are always experimenting with new things, combining technologies, trying to gain efficiencies, et cetera. We've heard of some prototypes out there in the market, but it's not something that's widely used at this point. And so, but it's some people like to dabble in the experimental, and so if you want to research it, feel free. But it's not something you see widely used and or economic at this point.
Thanks, Sean. And I think our next question is, how much more efficient are the current solar technologies compared to the 1970s efforts? And I think you touched a little bit on that, but maybe you could elaborate more.
Well, so what I was speaking to or referring to with the 70s, et cetera, was primarily in the context of solar thermal, and the efficiency is in thermal is considerably better. I don't have the percentages, but the primary gains that have happened in solar thermal over that time frame have been in the make of the equipment, the engineering that goes into the technology. Again, they kind of got a bad rap based on bad experiences of folks, and rightly so at the time. You know, they were leaking and causing damage to homes and businesses, and they end up getting a bad rap as such. But, you know, technology companies over the last 30, 40 years have invested a lot of money into R&D and have made these things work a lot better. Just in the last 5 to 10 years in solar PV, solar PV panels are, some of them are double the efficiency of what they were just 5 years ago. It wasn't abnormal to see solar panels of approximately the same size, be about rated as about half of what they are today by some manufacturers. And so the solar PV manufacturers especially are constantly tweaking and trying to extract every watt they possibly can out of the real estate that a solar panel provides. And so, like I say, it's not uncommon for a solar PV manufacturer to generate, 3 and 4 and 5 different iterations of a solar PV panel within a calendar year because they're gaining 5-10 watts at a time.
Thanks, Sean. Excuse me. And our next question, how hot do solar thermal panels get?
Remember that the solar thermal, the liquid inside of there isn't the actual liquid that you're using for your home or business, but it can get quite hot, and it can get 300 degrees plus. Of course, you wouldn't want to then bathe with that because that would be uncomfortable. But again, that's not the water that you're actually using, the liquid that you're actually using. It runs through a heat exchanger, et cetera, but it gets quite hot.
Great. I think we have time for one more question. The cost of PV panels keep going down, so should I wait to buy a system, or should I buy one now?
That really depends on the economics of the system and where you are at from a business perspective. Are you ready to invest now? If the question would have been asked to me before December, I would say you would probably want to buy sooner rather than later, because at that time one of the incentives, the federal incentive, was potentially going to expire at the end of this year. That actually got extended for a few more years as of December, and so it gives a little bit more time. But it just depends on where you're at from your business need. Do you have a need to offset your own energy or your own hot water heating costs? Do you have a need to want to attract the positive PR that often comes, the positive marketing capabilities that often comes with installing sustainable systems like solar thermal and solar PV? It's really an analysis that each individual business will want to do for themselves.
Great, and actually, I have one more question that came in for Jenny. Jenny, I'll unmute you. The question was solar thermal incentives. I don't believe there are solar and thermal incentives right now, but there are other tax credits available?
Yes, exactly that. So Energy Trust of Oregon does not offer solar thermal incentives any longer. There are state incentives for solar thermal, both for residential customers and through the Renewable Energy Development Grant that I was talking about earlier. And solar thermal is also eligible for the federal tax credit. But Energy Trust of Oregon no longer offers incentives for that here in the state.
Great, thank you, Jenny. And thank you, Sean. And that was our last question. I want to thank all of you for joining us today.